the level equal to 1,000 and the benefit equal to 1,000 for the same year, but the project has an important aim, for example, to save human life or to save sea mammals and so on, I can consider the project with a net benefit equal to 0. But I have to have those figures in the same year. If I consider that the benefits will come in the future, 3 years from now, 10 years from now, 20 years from now, that we have to consider in the cost-benefit analysis. Because in cost-benefit analysis we have some problems. One problem is related to the fact that we want to estimate not only financial cost and financial benefit, but also environmental cost and environmental benefit. I am considering the environmental cost and environmental benefit, but the same is true for social cost and social benefit in general. For human life, for example, for the life of animals, and so on. Okay? Then, once we have solved this kind of problem, so the way to estimate environmental cost and environmental benefit, social cost and social benefit, the other problem that I have in cost-benefit analysis is related to the discounting topic, to the discounting, because quite always I have to consider a cash flow with several years and figures spent over the lifetime of the project. Okay? And I have to find a way to calculate the present values. Okay? Once I have calculated the present value, I will have the possibility to calculate the net benefit. Is there a question?
Yes, I have a question.
Yes, please.
I'm sorry, I couldn't hear you very well while you stand up. I have a question. So we have to consider discounting in the future only when we have a cost-benefit analysis, and when we are studying cost-effectiveness analysis, we don't consider discounting, right?
It depends. In the case of cost-effectiveness analysis, I have showed you a very simple case with cost for alternative project, but for alternative project I can have also a list of costs for several years. In this case I have to consider the discounting problem even in the case of cost-benefit analysis, of cost-effectiveness analysis. I mean that the discounting problem has to be considered in each situation in which you have not a one-shot figure, not a one-shot cost, but a list of costs or a list of costs and benefits spanned over a lifetime for the project. Have you understood?
Okay, thank you.
Okay. I'm sorry if I have spoken far from the microphone, but I have only told that if we want to consider the project that we have in the slide, we have to consider that on the basis of net benefits, if I consider nominal values, the net benefit is equal to 0, but a project with a net benefit equal to 0 can be considered only if the cost and the benefit are in the same year. If the cost is in year 0 and the benefit is in year 3 or 5 from the present, I have to consider that
with the lens of today, the present value of a benefit equal to 1,000 is smaller with respect to the nominal value. Look at the second slide. If I consider present values, so discounted values, it could be a situation, I can have a situation similar to this. The nominal value for the benefit n years from now equal to 1,000 can become a benefit equal to 550 if I discount the figure. Okay, then I will teach you how we can discount a nominal value for the future. But at this stage, you can understand that if I will receive a benefit some years from the present, from the lens, if I consider this nominal value with the lens of today, the present value will be smaller with respect to the nominal value that I will receive in the future. Okay, sorry Manuela, because I have spoken without the microphone when I was far from the desk, but a colleague of you has told that a project like this with a cost equal to 1,000 and a benefit equal to 1,000 and a year from now could be considered if we have an important aim. For example, if we have an important aim related to human life. It is true, but it is true only if I have a benefit in the same year of the cost. Otherwise, I have to discount the benefit that I will receive in the future, and it could become a situation like this. With present value, if I calculate again the net benefit will become negative. Okay, because the benefit is only 550 and the cost is equal to 1,000. Okay, so what is the rationale that we have to consider when we have to speak about discounting? Usually, when we think about the future, we are used to consider the future in a different way. For example, if we have some money to buy a bond at the bank, okay, we are usually interested in the yield of the bond for the future. At the end of year 1, at the end of year 2, at the end of year 3, at the end of year 10. Okay? If we look at this, we can imagine that usually we think about the future when we have money that we want to invest now, and we are used to do some calculation, to have an idea of the yield that we will obtain in the future for the invested money of today. Okay? The rationale behind discounting is different, is the opposite. We have to consider a monetary figure in the future, and we want to calculate the present value of the monetary figure for the future because we want to judge the monetary figure with the lens of today. Here you have the usual formulas that we have to consider for compounding, to calculate the future amount of money if we have an amount of money to invest today. For example, to answer to this kind of chart, okay? So an amount of money K, if you have an amount of money K and an interest rate R, for 1, 2, 3, and years, okay? If you want to calculate what is the amount of money that you will receive at the end of the year, you have to do this. You have your amount of money K plus R, the interest rate, times the amount of money. If you consider the common factor, K times 1 plus R, okay? For example, if you have an amount of money equal 1,000 and an interest rate equal 1%, you will receive at the end of the year, okay, 1,010. 1,010. If you have an amount of money equal 10,000 and an interest rate equal 1%, you will receive at the end of the year 10,100. Okay? This is the formula that you have to consider to calculate future values, starting from an amount of money that you have today. Okay? This is not the idea of discounting. This is the idea of compounding. So, the way to calculate future values once you have an amount of money to consider for an investment today with a particular interest rate. Okay? If you want to invest your money, your amount of money for 2 years, then you have to consider the amount of money at the end of the first year for the same factor times 1 plus R, and you will obtain this formula. The sum that you will receive at the end of the second year will be equal to the amount of money that you are investing today times 1 plus the interest rate at the power of 2. Okay? If you have 3 years, the same, similarly. If you have n years, Sn equal to K times 1 plus R at the power of n. Okay? Now the question is, what is the value today of a bond with value K times 1 plus R a year from now? We can consider now the opposite question. If I have a future value equal to K times 1 plus R, okay, a year from now, what is the present value? What is the value for today? Okay. The present value can be calculated with a similar formula to the previous one, but with an opposite rationale behind it. The present value, PV, of an amount Sn to be received in time n is equal to present value equal to the sum that you have to receive n years from now divided by 1 plus R at the power of n equal, the same formula can be written Sn times 1 plus R at the power of minus n if you decide to do not consider the fraction. The present value is also called discounted value. So the present value formula is the formula that you have to consider if you want to calculate a discounted value for the future. A discounted value that for a monetary figure that you have in the future. Okay, let's give a look to this slide. Only to see the difference between future value and present value. if you have future value okay, if you have an amount of money to be invested today equal to 1,000 euro and you have an interest rate equal to 1%, if you remember the formula was this, is this, K, the amount of money that you have today to invest, times 1 plus R. So it means that if I want to calculate the future value, I have an amount of money K today, 1,000 euro, times 1.01, that means 1 plus 0.01, because an interest rate equal to 1% can be represented with 0.01, and you will calculate the amount of money that you will receive at the end of the next year. Okay? So 0.01 is the interest rate. If you want to calculate the present value, it means that you have an amount of money to be received in 2022. You have to divide this amount of money with 1.01 if 0.01 is the interest rate, the discount rate. And you will receive and you will be able to calculate the present value. Okay? 0.01 in the case of the calculation of the present value is the discount rate, while 1 divided by 1.01 is the discount factor. The name of this is the discount factor, while the name of the interest rate when you consider the present value calculation is the discount rate. Okay. Let's give a look to this example. Here I am calculating a present value for an amount of money S equal to 1,000 that I have to receive 20 years from now, and I am considering a discount rate equal to 0.08. If I consider a discount rate equal to 8%, it means that the present value of this 1,000 euro that I have to receive 20 years from now today represents only 214.5. Okay? If I change the R, instead of 0.08, I put 0.03, the present value increases and it becomes 553.7. So, what are the considerations that I can do with this slide? I can do some consideration. The first one, once I know the formula, it could be quite easy to calculate present values for future nominal values. Okay? Because with this kind of formula, I can calculate present values, even if the monetary figure will be obtained 20 years from now, 30 years from now, 100 years from now. Okay? But I have to define the discount rate. And the choice of the discount rate will change my present value result. Because in this case, if I consider a discount rate equal to 8%, my present value is 214. If I change the discount rate, instead of 8%, I consider 3%, the present value will become more than the double of the previous one. So the choice of the discount rate is very important because it has a strong influence on the present value result. Okay? One more consideration is related to the fact that if this amount of money equal to 1,000 is representing a far benefit for future generation, with the lens of today, it will be calculated only with 214 and not 1,000. So we are preferring money close to the present instead of money very far from the present. When we have environmental projects, it means that we are used to consider with smaller figures high benefit for the future. So we care more for the present generation instead of the future generation. Okay? If the sum of money equal to 1,000 that I have to consider for 20 years from now is representing a cost and not a benefit, is representing a cost, not a benefit, I have a similar consideration, because if I have environmental cost 20 years from now, but with the lens of today, I am considering these environmental costs very low, because I can consider for them only 214, okay, it means that when I have costs far from the present, the discounting calculation will give me smaller figures at present, in present term, and so it means that I don't care for future generation when I consider cost for them, or I can care more for present generation with respect to the consideration that I have for future generation. We will call this topic as a sort of tyranny of discounting. Okay, the tyranny of discounting means that when I have benefits very far from the present, in the far future, the discounting calculation will result in a very small value in present term. And the same if in the future I will have cost, environmental cost instead of environmental benefit. But we have to consider that this problem exists, and we have to define and we have to choose a proper and an optimal discount rate, because the choice of the discount rate will change my present value. As you can see in this slide, with a discount rate equal 8%, my present value is very low. With a discount rate equal to 3%, my present value is not as low as I have if I consider a discount rate equal to 8. Okay? So the choice of the discount rate is very important to avoid at maximum the tyranny of discounting. It is very important to calculate proper and optimal present value. Now I put a question to you. Now I have a question for you. If I don't consider the discount rate, if I consider a discount rate equal to 0, What is the meaning of zero as discount rate from a political perspective, for example? If you consider a discount rate equal to zero, what is the result of your formula?
Present value will be the same in the present and in the future.
The present value is the same of the future value. So it means that we care about the future as we care for the present. The consideration of a discount rate equal to zero corresponds more or less to an ethical position about the discount rate. It is a sort of ethical approach. If I want to maintain my ethics at the top level, I can consider a discount rate equal to zero. But with a discount rate equal to zero, it means that if I have a project like this, I can go on, because even if my net benefit is equal to zero, okay, I have to consider the benefit equal to 1,000 3 years or 5 years from now as a benefit received in the present time, in the same year that I have considered for the cost. Okay? So, the ethical position with respect to the choice of the discount rate is a possibility, but usually is not considered, because if you have a cash flow and if you have to calculate the net present value, and the net present value will be is the most important indicator to calculate the net benefit of your cash flow, okay, it is very difficult to consider a situation in which you can consider a discount rate equal to zero. With a discount rate equal to zero, you will have an ethical approach, okay, but you will have present values equal to future values. And so it corresponds to don't discount, okay? Okay, again about the cash flow. Let's consider again the same cash flow of before. Now, if I look at this cash flow, I can see 2021 that is representing the present year, but after the present year, I will have future years. 2022, 2027, 2040, for example, until 2040. Do I have the possibility to sum up all the net benefits? The answer is no, because in a cash flow like this, I don't have discounted values. All of these are nominal values. So this is the reason why I cannot sum up all the net benefits, because I am avoiding to considering the proper calculation of present values. What is the net present value? The net present value is the sum of all the discounted net benefits. The sum of all the discounted net benefits. Look at this formula. It seems a difficult formula, but it is very easy to be memorized, because you have the sum for I equal to 0 that runs to m for each net benefits for each year, and each one has to be divided by 1 plus r at the power of I. Let's give a look for I equal to 0. For I equal to 0, it means that you have to consider benefit for year 0, for the present, cost for the present, the net benefit for the present, divided by 1 plus r at the power of 0. But 1 plus r at the power of 0 means 1. So, if you consider the starting point with I equal to 0, you have to consider the net benefit for the first year. If you consider I equal to 1, okay, then you will have benefits for year 1 minus cost for year 1 divided by 1 plus r at the power of 1. For year 2, benefit for year 2 minus cost for year 2 divided by 1 plus r at the power of 2. And so on until you have reached the final year. Okay? The net present value is one of the formula that you can have in Excel. Tomorrow morning we will use Excel with some cash flow and you will calculate the net present value on your own with your PC, and it will be very easy because you don't have to calculate all the present values for each one of the years. But you can use the formula, the net present value formula in Excel to calculate with a few clicks the net present value. If the net present value will be positive for a particular project, you can consider this project. If you have two alternative projects and one of them has a net present value bigger than the other, you have to go on, or the indication can be to go on with the project with the higher net present value. So, a minute and then we will do a break, but consider that for each one of the net benefits, you have to calculate the present value. This is the rationale behind the net present value formula. If you calculate the present value for the first one, the present value is equal to the same value because the year is year equal to 0. And so the part of the formula that you have below the line will give you 1, okay, because you will have at the power of 0. Then you have to calculate the present value for year 2, the present value for year 3, and so on. And the sum of all the present values will give you the net present value. But the formula will do this for each one of the year in the same formula, without the calculation of each one of the present values. Okay? Okay. So, I think that we can have a break, okay? We can consider 20-minute breaks. We will continue starting from 10 and 41, 10 and 40, 20 to 11, 20 to 11. Okay. Okay, please. Okay. Okay. So I recall in a few minutes the question related to the cash flow and to the discounting problem. If we have cash flow like this, for example, P cost benefit minus cost and present value of benefit minus cost. Okay? So if you have time 0, time 1, time 2, time n, okay, cost of time 0, cost time 1, cost time 2, cost time n, benefit time 0, benefit time 1, benefit time 2, benefit time n, okay, benefit 0 minus cost 0, benefit 2 minus cost 2, benefit n minus cost n, okay. Okay, you cannot do the sum here, it is wrong, okay? You have to calculate the present value of each one of the net benefit. So it means benefit 0 minus cost 0, it is equal, and then benefit 1 minus cost 1 divided by 1 plus R, okay, and then benefits 2 minus cost 2 divided by 1 plus R at the power of 2. At the power of 2. Okay, and the same sorry. Okay, benefit 2 minus plus 2, okay, and the same here, benefit n minus cost n divided by 1 plus R at the power of 10. Okay? And in this case, you can do the sum. Okay? So, if you have a cash flow, then cost and benefit for different years, then once you have the net benefit for each year, you cannot do the sum. If you have calculated the present value for the net benefit of each year, you can do the sum. And the sum will give you the net present value. With the formula that you have in Excel and that we consider tomorrow, you will have in only one formula all the calculation of the present value for each year. Okay? But the rationale behind is the thing that I have showed you in this board, open board. Okay? Okay. Can you see? Okay. I think that we can maintain the open board here. I will check if you write something on the chart. Okay. So let's now consider what is the main method to give a value to the outputs. So the method for valuing the benefits of the output. As we know, the method that we have to consider is the way of calculating the willingness to pay, because the willingness to pay gives us the possibility to estimate the value of the output, even if the output doesn't have a market prices or a market value. Okay, demand schedule, willingness to pay, price, consumer gross benefit, and consumer surplus. I think that for the most of you, you know these terms, but in a few minutes I will repeat this. Okay. If you have a demand curve, demand schedule, it means that you have price, monetary value on the vertical axis, and a quantity, and the quantity on the horizontal axis. Okay. If you define, for example, the possibility to buy one of the goods that you are representing on the horizontal axis, and if you ask people about the willingness to pay for this unit of the quantity of the good that you have in the horizontal axis, it could be that the highest value that you will receive correspond to this, for example. Okay? I can ask you, what is your maximum willingness to pay to have now a bottle of water? Okay, I don't have here a bottle of water, but you can imagine that if I have a bottle of water and I want to sell to the person among you that will offer the highest amount of money, I can try to define a sort of kind of selling method, okay, to sell you this bottle of water. If one of you has a willingness to pay equal to €2, okay, I will receive this and I can represent this. Then some other of you will have a willingness to pay equal to 1.5, other 3 units, example. Okay, 1.5, 1.5, okay, then others with an offer of 1, okay, others with an offer of 0.7, okay, and so on. Okay, what is this? This is the representation of the offers of individuals that correspond to the willingness to pay of individuals to buy a certain good. Okay, the good could be represented by a bottle of water, and you know that the bottle of water has a market because you can buy a bottle of water in the water machine, for example. You can buy a bottle of water at the bar. You can buy a bottle of water at the supermarket. And you know that you have to pay a different amount of money if you want to buy it at the supermarket, if you want to buy it at the stadium, if you want to buy it at the bar, in the beach, and so on. But we can imagine that each one of us has a different willingness to pay to buy a bottle of water now, because it depends on the need that we have about the bottle of water. If we are very thirsty, we can be interested to pay even €1.5 or €2 or €1, even if we know that we can buy a bottle of water in the supermarket with 30 cents, with 20 cents. It depends on the need that we have about the bottle of water now. Okay, so what is this chart? This chart is representing the demand of individuals for this kind of good, and each one of the individual has an offer that is represented by a willingness to pay and not a market price. If I say you that you can buy a similar bottle of water in the machine in the campus by paying only 0.5, half an euro, okay, so the market price is this, okay, what does it mean? It means that if you have a willingness to pay above the market price, you will buy the bottle of water, even if I have the possibility to have more than one bottle, and I sell you each one of the bottles for half an euro. Okay? If someone of you has a willingness to pay equal to 0 or equal to 0.2 or 0.3, he or she will not buy the bottle of water because the willingness to pay is below the market price that I have fixed. But if I have only one bottle of water, I can sell the bottle of water to the best offer among you. Okay? So in this case, I can see that this is the usual representation of the demand of individuals for a certain good or a certain service, with or without a market price. If I have the possibility to define a market price, and the market price is, for example, 0.5, okay, if this is the market price, I can, even if a market price exists, I can interview people to ask them about their willingness to pay. So the willingness to pay gives me an information that is different with respect to the market price, even if I am considering a good or a service with a market price. Okay? If I have willingness to pay above the market price, I can understand that people will buy the good. If I have willingness to pay below the market price, I can understand that people will not buy the good. But I can consider the question about the willingness to pay even if I don't have a market price for the good or for the service. This is the rationale behind the use of willingness to pay for environmental benefits and for environmental cost, or for environmental cost. Okay? Because if I want to ask people about their willingness to pay to give money for a particular project to improve the quality of the air in the city, I can ask them about this and they can answer me with an amount of money that is representing their willingness to pay. Okay? So, what is the meaning of the sum of all the willingness to pay? What is the meaning of the sum of all the willingness to pay that I can obtain if I ask people about their willingness to pay for a particular project or for the will of, for the wish of buy a particular good, like a bottle of water. So what is the meaning of the sum of all the willingness to pay? If I consider the sum of all the willingness to pay, I am calculating the total value of the good that I am considering or of the service that I am considering. Because if I ask people about their willingness to pay and each one of the individuals will answer me with a particular willingness to pay, if I add all the willingness to pay, I can estimate the value, the total value for the good or the total value for the service. Okay? Because if I ask you about your willingness to pay to buy a bottle of water, and I come here and I will come here tomorrow morning with a box with many bottles of waters, okay? With your willingness to pay, you are answering me about the total value for you for my bottle of water, for my bottles of water, okay? But if I don't have bottle of water, but I have a project that involves the environment, I can ask people about their willingness to pay for this kind of project. And they will answer me with the value that they consider for this kind of project, but for the benefits of the project. Okay? So I have to estimate the cost to implement the project and the benefits of the output by asking people about the willingness to pay to obtain the benefits of this kind of project. Okay, so the question, okay, the demand schedule can be called also demand curve, and usually we have a demand curve that is similar to this. If I draw a new demand curve, I can have a situation like this. Okay, this is the demand curve. Here I have quantity, here I have monetary value. Monetary values can be represented by prices or by willingness to pay. Okay? If I have a market prices equal to this, if I have a market price equal to this, here I have willingness to pay above the market prices, here I have willingness to pay below the market prices. Here I have consumers that correspond to quantity of goods that will not be sold because the willingness to pay is below the market price. Here I have consumer with an higher willingness to pay above the market price, and they will buy the good or the service, if the good or the service has a market price. Okay. Again, if this is the demand curve, and I have individuals with a high willingness to pay, but they buy the good at the market price equal to PM below their willingness to pay, it means that they will receive the good and they will maintain some money in their pocket. Because if or you have a willingness to pay for a bottle of water equal 1.5 euros to have the bottle of water now, okay, but I sell you the bottle of water for €0.5, you will receive the bottle of water and you will maintain in your pocket €1. Because instead of 1.5, you have to pay only 0.5 and you will maintain €1 in your pocket. So, what is the meaning of the area represented by this? Okay. The meaning of this area is called consumer surplus. That means that for consumers that have a higher willingness to pay with respect to the market price, they can have a good situation because they can buy the good at the market price, and they can save money with respect to their maximum willingness to pay. Okay? If I don't have a good with a market, I can ask people about their willingness to pay to have a particular output without a market price, and they can answer me with some willingness to pay. So I have a demand curve also for this kind of good without the market price, and if I sum up all the willingness to pay, I will obtain the total value for the population that I have considered for this kind of environmental good or environmental service. Can you follow? So, the area below the demand curve, in the case of goods or services without market prices, is representing the total value that people consider for this kind of good or service, even if this kind of good or service doesn't have a market price. Okay? So, in the case of goods and services with market prices, people can have a sort of surplus, consumer surplus, only in the case in which they have a willingness to pay above the market prices. Otherwise, when we consider goods and services without market prices, okay, we can estimate the total value for individuals by asking them about their willingness to pay. Okay? Okay. So, the algebraic sum of willingness to pay values is the appropriate measure of the benefits of a policy. If I consider a policy and if I ask people about their willingness to pay, then I can sum all the willingness to pay. Some of the individuals can have negative willingness to pay because they don't like the policy. Okay? But if the algebraic sum will give me a positive value, it means that the total willingness to pay can be considered as positive. Okay, what are the main issues that I have to consider about willingness to pay? There are some limits, okay, some limitations. I have limitation in the aggregation of willingness to pay amounts across individuals. Dependence on willingness to pay on the distribution, because there is a dependence of willingness to pay on the distribution of wealth in society, and because I have to consider the standing issue. Whose willingness to pay counts in the aggregation of benefits? And I will answer to this question now. Dependence on willingness to pay on the distribution of wealth in society. The willingness to pay of a person to obtain a desired policy will tend to be higher the greater the wealth that he or she has available. So, if I consider a question with which I ask people about the willingness to pay, the willingness to pay can be, the willingness to pay values can be very high if I have people that are rich, okay? Or can be low in absolute value if I have people poor, if I have poor people. So, the sum of willingness to pay, the benefit measured in cost-benefit analysis, depends on their level of wealth. So, if I have change in the distribution of wealth, the sum will change. And what about if I have to rank alternative policies? If I know that there is a dependence of willingness to pay with respect to the distribution of wealth in society? Moreover, when we collect information about willingness to pay of individuals with a sample survey, if I ask you about your willingness to pay for a particular project or for a bottle of water, okay, you will give me heterogeneous values, different values, and then I have to calculate the mean of your willingness to pay and or the median of your willingness to pay. What is the value that I have to consider? We spoke about this last week. If I consider the mean of the willingness to pay, the mean can be higher with respect to the median because I am considering all the values. Okay, I am considering all the answers, the small values, the smaller values, and the higher values. Why? If I consider the median is usually below the mean because with the median I am considering a sort of position average value. Look at this chart. Look at this chart. A minute, because I closed this. Okay. Okay, look at this chart. This is a chart that represents the UK income distribution, okay, when we consider all the households that we have in UK, okay. They are old data, but they are able to represent the situation that I want to consider. Okay, if I have an income distribution like this, it means that I have a positive skewed distribution because I have a long tail on the right. Okay? With a long tail on the right, I have that the median value is above the mean, okay? But it means that if I consider the mean, it seems that UK households are quite rich with a mean of income equal to 463. But if I consider the median refers to me this: the 50% of individuals of households live with an income below 377. Okay, so the difference between the median and the mean is related to the fact that if I look at the mean, I can suppose that people stay well, okay, because the average value for income is equal to 463 pounds. But I cannot say that the 50% of household lives with an income equal or above 463. Okay, I have to consider the median value. So, from the political point of view, the median and the mean are very different, because if I look at the median, I can say that the 50% of households lives with a monthly income equal to a value below 377 or above 377. But I cannot say the same thing if I consider the mean. Okay? If I ask people about their willingness to pay, I will obtain similar situation. So the mean is bigger with respect to the median, but if in the future I have to ask people to pay for two, I cannot ask them to pay the mean. Okay? Because the mean is too high for the 50% of individuals or for a part of the individuals. If I want to consider the desires of the 50% of individuals, I have to consider the median value. What about the standing issue? Because the median and the mean and the distribution of wealth has effects on the willingness to pay and on the future value that I can consider to ask people to pay. But the standing issue is a different issue. Whose willingness to pay count in the aggregation of net benefits? I have to consider the definition of society, of the involved society. National level, I have to collect information about citizens. Do I have to consider also illegal inhabitants or not? And do I have to exclude socially unacceptable preferences? For example, some people would be willing to pay for the opportunity to have sexual relationship with children. Do I have to consider this kind of people? Okay. Clear and accepted legal sanction may help to identify preferences that should not have standing. So with the standing issues, I have to consider what is the range or what is the definition of society that I have to consider. All the society without the consideration of illegal inhabitants or with the consideration of illegal inhabitants. And then, what about future generation? Whose willingness to pay count in the aggregation of net benefits? Only the inclusion of preference of the present generation, or do I have to include also the preference of future generations? Okay? Some policies adopted today may have impact on people not yet born, but few policies involve impacts that involve only the future. Most people alive today care about the well-being of their children, grandchildren, and so on. So, in many situations, we are used to ask willingness to pay of individuals, of present generation individuals, without considering the desires of future generation. Okay? But even we have to do this consideration, sample survey to ask people about their willingness to pay for projects are very frequent, But more or less, in all the sample survey, we have to calculate the median of the willingness to pay and not the mean, or not only the mean. So, what is the glossary list of terms until now? Until now, we have spoken about Pareto efficiency because cost-benefit analysis has a link with Pareto efficiency, because we are searching for projects with positive net benefits. A positive net benefit means that we are able to pay the losers. Okay? Then, what about the decision rule? The most important decision rule is the net benefit decision rule. We have to calculate the net benefit, and we have to calculate a list of benefit, a list of cost, a list of net benefit, and a list of present values for the net benefits to obtain the net present value. Okay? When we consider the decision rule, there is another decision rule with respect to the net benefit decision rule, and it is linked to the benefit cost ratio. The benefit cost ratio can be used, but the most important one is linked to the net benefit and not to the benefit cost ratio. But I will tell you more about this point. Then we have spoken about discounting. Discounting is different with respect to compounding. Compounding corresponds to the logic that we follow when we want to calculate future values for an amount of money to be invested today at a particular interest rate. Discounting corresponds to the opposite logic. We have future values, but we want to calculate present value to decide today. Okay? Nominal values are values written in my cash flow without considering the present value for them. Future values and present value, we know the difference between future values and present value. And what is a cash flow? Cash flow is a sort of table with a list of years or time reference, benefit, cost, net benefit. Okay? And the net present value test corresponds to the sum to the present value of the net benefits that you have in your cash flow. Okay? Okay. So, what is the summary? What is the list of the things to do when we have a project and when we want to consider this project to decide if the project is a good project or not, and if we want to compare this project with respect to the status quo or with respect to an alternative project. Okay? For example, if I have a purpose to improve the air quality, to preserve a forest, or to build a new dam, or to reduce CO2 emissions, or to reduce marine litter, or if I have a private project, okay, I can have different aims, different purposes, okay. I have to identify the list of the effects, the list of the consequences. I have to identify the time span, so the lifetime of the project. I have to estimate quantitative figures for the effect, for example, as in the example of the transport, of the different transport modality that are able to link the two towns, new highway with buses and new railway, okay, new railway. In this example, in that example, you have the quantification of the effects. Then you have to monetize the effects. You have to define the cash flow with figures, data. You have to choose the discount rate. You have to calculate the net present value, so the net present value test. After all, you have used cost-benefit analysis as the decision-making tool, as a decision-making method to decide if it is a good idea to go on with a particular project or not. Okay? So, first of all, you have to define your aim, your purpose. Then you have to identify the list of the effects. Then you have to put quantitative values for the effects. Then you have to estimate monetary values for the effects. At the end, you will have cash flow. Once you have a cash flow, it is quite easy to calculate the net present value. Okay? The same if you have more than one project, so 2 or 3 alternative projects, and the same if you have only one project and the status quo. You have to do the same thing for your project and for the status quo to decide if it is better to go on with the project or to remain with the status quo. Okay? Okay. Now, after this introduction to decision-making methods and the logic of the resource valuation, because behind the logic of the resource valuation, you have the key concept of willingness to pay, because the willingness to pay is the concept that helps you to estimate benefits and costs, even if you don't have market values. Okay, so we are arranging all the consideration that we need for project appraisal, so for project valuation, because if you remember, we can have project, policy, program. A particular project can be the building of a dam, the building of a bridge, or the purpose of building, define a new public garden, or a project to improve the quality of the air, or a project to face climate change. Okay? All these kind of projects can be considered. But look at the 3 colors that you have in this slide. When we have project appraisal, we can have private project appraisal, social project appraisal, or environmental project appraisal, environmental cost-benefit analysis. Cost-benefit analysis can be used even if you have private project appraisal, expenditures and receipts, and again, you can calculate your net present value test even if you have only expenditure and receipts. Because on a private basis, a firm, an entrepreneur, an household, on a private basis, this kind of subject is able, it wants to consider expenditures and receipts, okay? But you can calculate the net present value test even if you have only expenditure and receipts. If you consider the social project appraisal, in the social project appraisal, you have to consider all the externalities, negative and positive externalities, okay? Once you have estimated negative and positive externalities, so once you have taken into account negative and positive externalities, you can calculate the net present value test. So it depends on the figure that you have and on the kind of project that you have, but at the end, you can always calculate the net present value test. If you have a project that involves the society, but with environmental effects, we can call it a sort of environmental project appraisal and or environmental cost-benefit analysis, but you have to consider all the environmental impacts. At the end, you can, again, calculate the net present value. So the logics are very similar, but you have to consider by yourself if you are facing a private project or a social project or an environmental project. If you have an environmental social project, you have to consider all the externalities, okay, and all the environmental impacts, both the positive ones and the negative ones. Okay. If you consider a private project appraisal, you have to estimate only the expenditures and the receipts. And then you can calculate the net present value test. Look at this. If you have expenditures indicated with E, okay, the present value of your list of expenditures will be E0, E1 divided by 1 plus I, plus E2 divided by 1 plus I at the power of 2, because you are in year 2, and the same when you reach year T. In some formulas you have different kind of notation, T instead of N, okay, but the formula are the same. Then you can calculate the sum of all the present values. You can do the same for the receipts, okay, and then the present value of the project is given by the difference between the present value of the expenditure and the present value of, the present value of the receipts and the present value of the expenditure, okay. And the project should go ahead if and only if the net present value will be above or equal to 0. Okay? So the logic of cost-benefit analysis is not difficult. The difficult things is to organize are related to the organization of your data and to the estimation of your figures, especially when you have to deal with environmental project or social project. If you have to deal with private project, it could be easier to estimate expenditure and receipts. Okay? Once you have estimated the expenditure and receipts, you have to remember always that you have to calculate the present values. And the net present value is the final one. Okay? Look at this example. A few minutes to look at this and to try to define your consideration. What are your considerations about this slide? You have a list of expenditures, a list of receipts for a private project that goes from year 0 to year 4. Year 0 is representing the present year, okay? Then you can calculate the net benefit for each one of the year, but you know that you cannot sum all the net benefits because they are referring to different years, okay? But you have here the calculation result, the result for the net present value test at different values for the discount rate. What is the difference that you can see when you consider a discount rate equal to 5% or a discount rate equal to 7.5% or a discount rate equal to 10%? What are your considerations now? If you choose the lowest discount rate, you will have a net present value that is positive. So it seems that the project is a good project. But if you decide for a discount rate that is the double of the first one, your net present value test will give you a negative value. And the negative value is not good to go. A negative value tells you that the project is not so good. And you can decide on this basis to do not go ahead with a project like this. If you choose a discount rate equal to 7.5, the net present value test gives you 0. Okay? So, this is a slide for teaching purposes, of course, just to say to you that the net present value test gives you a different value depending on the discount rate that you choose. Okay? Usually, when you have a project with social or environmental positive effect, we are used to select a small discount rate. Okay? But when we have private projects, we are not so, we cannot agree to define a very small discount rate. Because if we have the possibility on a private basis to invest money and to get for that amount of money, for this amount of money, a particular interest rate, okay, we can prefer to invest money to obtain an interest rate after 1 year, 2 years, or 4 years, instead of investing money in a particular project, different from the bank bond, for example. Okay? So, we will see that when we deal with environmental desired effects, environmental project, social project with positive effects, we are used to consider lower discount rate. When we consider private project, then the private person can consider a low or an average discount rate depending on the alternative that he has for the use of the money. Okay? Social project appraisal. When we consider social project difference with respect to the private project appraisal is this. We have to take into account externalities. Sorry, Daniel, I have seen your answer only now. Yes, when R increases, the net present value becomes negative. Okay, it is correct. Okay, so when we deal with social project appraisal, we have to estimate externalities. So we have to take into account externalities, and then we have to calculate the net present value test. So, cost-benefit analysis can be approached in two ways in social project appraisal. As an extension of private appraisal where externalities are taken into account, or in terms of social welfare enhancement. You have to follow the usual stages for cost-benefit analysis. You have to identify your project or policy. You have to provide an estimation, forecast for all the consequences, all the effects of the project, of the policy, for all the affected individuals in each year of the policy project lifetime. Then, you have to express consequences and effects in terms of monetary gains, losses, for the aggregation to a net present value number. So, if you have a social project appraisal, you can try to define this. Estimate the expenditure, estimate the receipts, and estimate the value of externalities. Or you can try to estimate benefits and cost for all the individuals involved by the policy or by the project. Okay? But the stages are the same. You have to identify the policy or the project. You have to forecast all the consequences, all the effects. Then you have to put a monetary value for each one of the consequences and each one of the effects. Okay, look at this table. Net benefit impacts consequent upon an illustrative project. You have individuals, for example, A, B, C, and you have a very small society defined with these three individuals. Okay? Time period 0, 1, 2, 3, and overall. Okay? You will have net benefit for individual A at time 0, net benefit for individual B at time 0, and so on. Okay? So, the net present value will be given by the sum of all net benefit, of all the present value for all the net benefits. Because as you can see, you have net benefit for year 0, net benefit for year 1 divided by 1 plus R. That means that you are calculating the present value of net benefit for year 1, the same for the net benefit of year 2, and the same for the net benefit of year 3. And the sum of all these terms will give you the net present value. Okay? And generally, you want to go ahead with a project like this if the net present value will be above 0, will be positive. In the private project appraisal, we have considered to go ahead with positive net present value, or even if the net present value will be 0. In the case of social appraisal, we are used to consider only policy or project with a positive net benefit. Okay? Last 3 slides, with the environmental cost-benefit analysis, with environmental project appraisal, okay, we have to consider environmental impacts. Look at this. If you have the possibility to develop an area and to abandon the wilderness that is present in the area before the development, okay, we will have some benefits for development and some costs of the development, okay. If we avoid to consider environmental impacts, we will have net present value equal to the sum of all present value for the net benefit, that is the same with respect to the calculation of the present value of all the benefits minus the present value for the costs. Okay? But if we have that this difference can be named with NPV with a small sign, then the proper net present value taking account of environmental impact is benefit of development minus cost of development minus environmental cost. Okay? So EC stands for environmental cost. And you want to go ahead with this project only if the net benefit of development is bigger, is above the value of environmental cost. Okay? This is a possible notation of environmental project appraisal, of environmental cost-benefit analysis, because if you want to avoid this kind of notation, you can list all the consequences, all the effects, and you can estimate costs and benefits for all the consequences and all the effects. And then you will have your cash flow and the possibility to calculate the net present value. Okay, the net present value test is the same, even if you have a private project or a social project or a project with environmental effects. Okay? So the test is the same, but the figures that you have to estimate to calculate the net present value depends on the kind of the project that you have. Okay? Are there questions?
Sorry, Professor, I don't know if you can hear me.
Sorry, can you repeat?
Can you hear me?
Yes, yes.
I would ask you about the environmental appraisal. When we consider the cost, benefits, and economic cost, the benefit and the cost are mainly economical ones, while the environmental cost is regard ambient and the environment, or kind of.
With this notation, we are considering that benefit of development and cost for development are economic benefit and economic cost, in the sense of financial benefit and financial cost. Okay? Because we are considering environmental cost in a separate term. But, in my opinion, we can also avoid to use this notation, but we are to be sure to consider all the benefits and all the costs, both the economic and environmental ones.
Okay, thank you.
Okay. Other questions?
When comparing status quo to a given project,
A minute.
when you compare a project to the status quo, does it make sense to look only at the future value? I mean, since status quo is current, so if it has a negative present value, then you would just be evaluating the project without, I don't know.
Yes, when you consider the project and the status quo, again, you have to consider all the economic consequences to go ahead with the status quo, or the economic consequences to go ahead with the project, with the proposed project. With economic consequences, I am considering all. I have used this kind of notation because this kind of notation for environmental cost-benefit analysis is the notation that you will find on the book. But in my opinion, it is not correct to define cost and benefit separated with respect to the environmental cost. Because we are considering project with environmental effects. And we are used to list all the consequences in economic terms. And in economic terms, environmental has value. The society has a value. Okay? Okay, answer? Yes. Other questions?
Okay, now we have to answer to the most important open question, but tomorrow we will speak about this open question. The open question is now how to choose the discount rate R to calculate the net present value test, because we have seen that when we change the discount rate, we can find a positive net present value or a negative net present value. But it changed a lot, because the rationale that we want to follow is to go ahead with a project only if the net present value is positive. But if we change the discount rate and the net present value becomes negative, it is a problem for us. So we want to decide for the proper discount rate or for the optimal discount rate to be sure that the net present value test tells me the truth, helps me to decide if I have to go ahead with the project or not. Okay? Okay, so let's see tomorrow, and please bring with you your laptop for the in-present students. For the online students, you have the personal computer with you, and tomorrow we will use some Excel functions. Okay? Thank you very much. Have a nice afternoon.
Hi, thanks.
Bye.
Thank you, Professor. Bye.
Thank you. Bye.